Hello, and welcome to the second part of your Python Basics lecture. So today we're going to focus a lot on operators, and this is hopefully going to be a bit of a short lecture because I think the best way to learn about operators is to actually use them, which we'll do more in class. However, I want to go over some of the basics here. First, let's talk about comparison operators. Comparison operators might look familiar, at least some of them. These output booleans, true or false, depending on whether the comparison you made is true or false. Sometimes, therefore, we call these boolean operators as well. Now, the first one you can hopefully figure out what it does, but it does look a little different than we expected. In Python, remember, so far we've been using == sign to mean assignment. In other words, put what's on the right into the container on the left. However, when we want to compare whether two things are equal, we use == signs for the equal to operator. This returns true or false depending on whether the comparison you made is true. If we, for instance, said 1 = 1, that would return true because 1 actually does equal 1. However, it would return false if we said 1 = 6 because 1 doesn't equal 6. The next comparison operator is the opposite of that. It's a not equals to, which we use with an exclamation point and an equal sign, which basically says true if the two things compared on the left and the right are not equal to each other, and false if they are equal to each other. These four on the bottom should look very familiar from math class, with a greater than, a less than, a greater than or equal to, and a less than or equal to sign. I'm not going to go over what those mean because you probably know, but again, you're comparing what's on the left and the right-hand side. Let's go to Atom to run this code in Python. All right, so let's do some comparisons. I'm going to go ahead and print out the comparison 1, == 1. And this is basically asking Python, is 1 equal to 1? Now, we think this is true, but let's double check and see if that's what Python thinks. I'm going to open Platformio, get a new terminal, go ahead and check that this is the right folder, and then run my code. I'm going to say Python. If you're on a Mac, you're going to add a 3, and then the name of the file, Python basics _4_cw.py. And I'm going to go ahead and run this, and the output of this program is true, because 1 is indeed equal to 1. Let's go ahead and try one that we think is false. So I'm going to go ahead and say print 1 = 6, and let's go ahead and see if Python agrees with us that this is false. We're going to go ahead and run. Yep, it thinks that's false just like we do. I'm going to go ahead and comment these out, and then let's look at some of the other comparison operators that we talked about. First, let's do the not equals to. So we can say, for instance, 9 is not equal to 6 divided by 2. So this is comparing what's on the right-hand side, 6 divided by 2, with what's on the left-hand side, 9. Let's go ahead and run this and see what Python says. Awesome. So Python says true because it is true that 9 is not equal to the output of this, which is 3. Finally, let's try some of those greater than or less than operators. Let's go ahead and print out 3 is less than 3. Now, let's see what Python has to say about this. Interesting. Okay, so Python said that this is false, which, when I think about it, makes a lot of sense. 3 isn't greater than 3, it's equal to 3. If we wanted to test whether something is greater than or equal to, we can add the equal sign here, and when we run this, Python will now output that this is true because it is true that 3 is either greater than, which it's not, or equal to, which it is, 3. All right, now that we've talked about comparison operators, let's talk about int operators, which are basically operations you could perform on integers. These should look very familiar from every math class that you've taken, with a couple exceptions. Plus and minus look very familiar, one dividing sign looks familiar. However, we also have something called floor division, which is 2 division signs, and we'll talk about that in a second. Then we have an asterisk to represent multiplication, a new one with a % sign, which we call modulo, and then 2 asterisks to represent to the power of. So for instance, you can see here, 2 to the power of 2 would be represented like this in Python. All right, let's go to Atom. All right, so let's basically use Python as a calculator. I can print out 1 plus 3, and that will do the operation for me of adding 1 and 3. Let's go ahead and see what that output is. Oh, as expected, it's 4. We can also do things like multiplication, 2 times 8, and output that as well. Again, that gives us 16. Now let's go ahead and comment those out and talk about some of the operators that maybe looked a little bit unfamiliar. First of all, we had regular division, which should be a little bit familiar. For instance, let's say print 10 divided by 3, and we get the output as expected of 3 1/3 because 10 divided by 3 is about 3 1/3. All right, well, sometimes we don't want to ask what is 10 divided by 3. We want to ask how many times does 3 go into 10 evenly? And we can do that using floor division, which is those two division signs in a row. When I print out 10, floor division 3, this is going to tell us how many times 3 goes into 10 evenly. It's not going to have a decimal, it's just going to be the number of times we can have 3 go into 10. So let's go ahead and compare these, and you can see that when we use floor division, we get back an integer because it's telling us how many times evenly 3 can go into 10. Let's just try another one just for our sake. So we'll say print, and let's comment these out, print 100 divided by floor division by 6. This will tell us how many times 6 can go into 100 evenly. So when we run this, we get 16. So 6 can go into 116 times, but there's probably something left over at the end. In order to get that, we can use our new operator, modulo. So we can say 100 modulo 6, which will tell us what is the remainder after 6 goes into 100 evenly. In this case, let's go ahead and run that. It's 4. So 6 can go into 116 times, and there is 4 left over. All right, this is just something I want to quickly point out. Print 10 modulo 2. This tells us what the remainder is after 2 goes into 10 evenly. Let's go ahead and run that. Oh, it's 0. So 10 is divisible by 2. Now, I wonder what would be interesting about all the numbers that are divisible by 2. We'll have to think about that more in class. All right, let's just go over some of the other operators. So for instance, we saw that we can use 2 asterisks for to the power of. For instance, 2 to the power of 3, in our heads, we know that should be 8. Let's see what Python says. Awesome, Python agrees with us, it is 8. Now, we just use Python to do a ton of math, and I want to talk a little bit about what happens when you use both floats, which remember have decimals, and ints, which do not, in a math equation in Python. Floats actually have a little more information than integers because floats allow you to have a decimal place and ints don't. So if you ever converted a float to an integer, you would just basically be chopping off that decimal place, which means you're losing information. Therefore, when you combine floats and integers in an equation, you're usually going to get back a float because we don't want to lose information unnecessarily. However, there are some exceptions. For instance, we just talked about division versus floor division. Regular division will always return a float, and this happens no matter whether you used floats or ints originally. Let's go ahead and check that out. All right, so let's do some addition. Let's print out 1 plus 2. So we are adding 2 integers together, and as expected, we get an integer out. What if we add 2 floats together? We'll say 1.0 plus 2.0. Let's go ahead and run that, and we can see that we get a float out as well, which makes sense because both the numbers we put in were floats. Now let's see what happens when we add a float and an int. Go ahead and run that. As you can see, we get a float out. Remember, floats have the potential to have more information, and we don't want to lose information unnecessarily, so when we combine floats and ints, we get floats out. All right, there are some exceptions like we talked about. For instance, when doing division, we're always going to get a float out, even if we put in integers. For instance, let's print out 10 divided by 3 again. Go ahead and run that. Now, even though 10 and 3 are both integers, our answer is a result of a float. Basically, I guess the lesson here is that if we're ever in doubt, we want to default to a float, which has a little bit more potential to have information, instead of losing information by converting a float into an int unnecessarily. All right, despite what the screen might show, I'm going to keep my cool here as we talk about precedence. You might know this in math as the order of operations. Just like PEMDAS that you learned in school, computers and languages like Python have orders that they execute operations when there's multiple in a single line. In terms of precedence, it's actually very similar to PEMDAS. Precedence goes from parentheses first, then we do exponents, which in our case is 2 asterisks, then we do plus and minus for positives and negative numbers, then we do any of our multiplication or division. That includes multiplication, division, floor division, and modulo. Next, we'll do plus or minus as in addition or subtraction. And finally, if we have multiple operations on the same level, we will go from left to right. So for instance, if you look at this line right here, we have multiple operations. So we have to figure out which one to do first. In this case, we can go through and say, okay, multiplication is higher than addition. So we'll probably do 3 times 5 and then do 2 plus 15, which is the result of 3 times 5. Now, if we wanted to not do that and instead do 2 plus 3 times 5, we would need to make sure that we're using parentheses, which again are always executed first, to clean up our code and make sure it's clear the order that we want Python to execute all of these operations. Now, give yourself a second and figure out what would the answer to this be on line 4. We have a bunch of different operations, all with different levels of precedence, so take a second and try and think which one would be executed first. Okay, I gave you a second. Pause if you haven't figured it out yet. All right, the answer here is that the first thing that we have, the highest order of precedence, is the power. So we would take 5 to the power of 2 to get 25. Now, the next highest thing is a multiplication. So we would take 3 times 25, which is 75. And finally, the last order of operation here would be the plus. So we would take 75 plus 2, and we should get the answer of 77. But don't take my word for it. Let's go to Python and check. All right, so here we have the line of code that we saw before, and it's not very clear. If you didn't think about the order of operations or the precedence, it'd be hard to figure out what this answer is, but let's see what Python says. We'll go ahead and run this, and as we calculated, the answer is 77 because we're doing power, then multiplication, and then addition. Now, I would argue that relying on people to know precedence or orders of operation is actually not that smart. We can always use parentheses in our equations to make sure it's clear what we want executed when. So for instance, I might rewrite this. Let's copy and paste here. I might rewrite this with parentheses like this, because this tells us, okay, well, we want to do this operation first, and then we want to do this operation, and finally, we want to add 2 to the result of all of that. Now, it's not the easiest thing in the world to read, but at least we can see that this has a very specific order, and we can tell what that order is without knowing the order of operations or precedence in Python. All right, here's an example of another very complicated string of operations. Take a second, pause the video, see if you can figure out what the answer is on your own. All right, hope you did that. I'm going to go ahead and comment this out, and let's print out the answer. Okay, so the answer is 76. Hopefully you got that right, but let's talk through how Python got that answer. So when we look at this here, you can see that 7 to the power of 2 is the highest precedence here, so that will execute first, giving us 49. Then we'll go through and see that the next highest precedence is this 4 times 6, so we'll do that, which is 24. So now we have 1 plus 2 plus 24 plus 49. Now that we have multiple operations on the same level of precedence, we're going to go left to right. Not that it matters that much. So we're going to do 1 plus 2, which is 3, plus 24, which is be 27, plus 49, which, as Python told us, is 76. All right, let's go ahead and run that again just to double check, and yes, it is still 76. But again, I think it's really silly for you to rely on people's knowledge of precedence in order to understand equations like that. So I would instead add parentheses here and there to make sure that people can understand without remembering their order of operations what this should be. So for instance, I would do this, and that way it makes it clear that we're adding 1 to whatever the result here is and whatever the result here is. All right, let's comment that out and do one more for good luck. All right, let's look at this one. Again, pause the video really quickly, see if you can figure it out yourself, but then let's ask Python. All right, hopefully you've done it yourself. Go ahead and run that. And Python says the answer is 49. Let's see how we got that. All right, so let's look through our order of operations. The first thing we see is 4 squared, which should be 16. Now that we have 16, the next operator that we'll do is actually this floor division here. This is because if we have 2 items that are at the same level of precedence, we're going to go ahead and go from left to right. So I'm going to do 6 floor division 2, which actually should give you 3, because 2 goes into 6 3 times evenly. So now we have 3 times 16. So now we have 3 times 16, because again, between times and plus, we would do multiplication first. So again, we should have 3 times 16, which is 48. And then last but not least, we will do the +1 operation, giving us 49. Now, you may have noticed from the picture on the screen that I hate when people do all of these order of operations or PEMDAS brain teasers. I think, as I said before, that it is so important to make sure that your code is readable. And readable probably means you don't want people to have to think through the precedence of your code in order to figure out what the operations you're doing are actually doing. You might see on social media all of these like brain teasers circulating where they'll show you something like this and they'll say, "What's the answer? Most people get it wrong." And most people get it wrong because most people are not thinking of the order of operations or precedence. And while I get that those are brain teasers meant to see if you remember everything, I think that's silly. And I think that you should always write your code in a way that is clear so that you are using parentheses or whatever else you need to make sure that people don't have to remember precedence in order to figure out what your order of operations is. All right, rant over. Let's talk about a couple shortcuts. Now, there are a lot of times that we might want to increment variables. For instance, we might want to increment a variable by 1. So we say every time we run a line, we want to add 1. Well, we can do that with all of these shortcuts. These shortcuts for plus, minus, division, multiplication are basically ways to do a equals a plus 1, but in shorter form. Let's go to Atom to see how this actually works. All right, let's talk about shortcuts. I'm going to make a variable called a and set it equal to 1. And then I'm going to say a equals a plus 1. This basically tells us take what the value of a used to be and add 1, and then reassign that all back to the variable a. So when we print out a, we expect it to be 2. Let's see if that's what Python thinks. That is exactly what Python thinks. All right. Now, what if we wanted to run this code on line 39, but more elegantly and efficiently? Well, we can do that by saying, and I'm going to copy and paste all of this here. We can instead do that by saying a plus equals 1. This is the exact same thing as saying a equals a plus 1. So let's go ahead and run this and make sure it still outputs 2. And it in fact does. And we can do this with minus if we wanted to subtract. So it would be a equals a minus 1. And this should give us 0. Beautiful. We can do this with multiplication and division if we would like to. These shortcuts aren't necessary, but they basically give us a shorter way of doing common things like incrementing by 1, subtracting by 1, etc. We can even do cool things. Let's comment this out, like a equals 1, a plus equals a. This is interesting because instead of saying, so let's put what this is equal to, this is the same as saying a equals a plus a. And let's make sure that's actually what happens by printing out the value of a. All right, let's go ahead and run this. Beautiful. So we can see that we took the original value of a, added itself to itself, and returned that to a again. So now a is equal to 2. Interestingly, let's see what happens when we run this line again. So again, we're saying a equals 1, a equals a plus a, and then a equals a plus a again. Let's see what the result is. Interesting, so the answer is 4. This is because on the first time that we do this, a is 1, then a equals a plus a, which is 2. And then again, a equals a plus a, which is now 2 plus 2, so 4. And you don't have to use this if you don't want to, but it is a really fast shortcut if you want your code to just look a little bit shorter. All right, last, let's talk about the math module since we've been doing so many operations. We talked a little bit in a previous lecture about importing code that other people have written for us in order to use in our own Python programs, and we do that using import statements. Import statements typically go at the top of your script. They don't have to, but I think it's best practice to put them there because you do have to make sure you run them before actually using them. Now, in general, when we import a package, if we want to use a function from that package, we have to say the name of the function dot the name of the function we want to use. And for instance, the math module has a lot of useful functions for us like square root, sine, and log. Let's go to Python and test those out. All right, so the first thing we need to do if we want to use the math package is to import it. We can say import math. And now, once our code runs, we will have access to any function in that math module. For instance, if I want to print out math.sqrt for square root of 100, I can do that. And when I run it, I get the answer is 10. Similarly, I can print out math.sine of 0, and I will get the sine of 0. Notice that we're saying the name of the package, a period, and then the name of the function that we want to use. If you want to Google the documentation, the math package has a lot of different fun functions that you can use. However, we're just going to cover a couple today, the last one being the log function. For instance, we can say print math, the name of the package, dot the name of the function I want to use, and we'll say math log of 1, and go ahead and run that, and we can see the answer is 0. Now, just for fun, let's go ahead and comment out the import math line and see what happens. Oh no, okay, so we got an error. We actually got a name error this time because we didn't import the math code or the math module for us to use. Python's a little confused when we say, hey, from the math module, grab the square root function. Python is basically telling you here, you didn't import any math module. And so if you ever forget to import a package, you might get an error similar to this one. Let's go ahead and uncomment that code just so you know not to do that in the future. And one more thing, let's copy this. Remember, you have to import before you use a module. So even though the import statement is in our script, when we run this, we get the same math error or name error that we got before because we didn't import math before using it. This is why we tend to put import statements all together at the top of a script, just because there's literally nothing else before that, and so we can't accidentally make the error of importing something after we use it in our script. All right, that was a lot of math, so I'm glad you hung in there. That's all I have for you. I will see you next time.